Okay, once again, good afternoon, all. Should we start now? Am I audible to all?
Yes,
Yes,
sir.
sir. Let's continue.
Okay, so in the last lecture, what we have seen about the insertion sort algorithm. The logic was we have assumed that the first element or the single element is always sorted, and we will insert the element into already sorted array. That was the logic of the insertion sort. We have seen the algorithm also, and through an example, we have understood the concepts too. Now I am moving on to the next, that is selection sort. Selection sort, again, with the help of name, you can try to find out a clue for that algorithm. Select. Okay. So what we can say that for this algorithm is selection sort is again a sorting algorithms which needs to select the smallest element in the array. What we need to do is we need to select the smallest element into the array. So in this way, you can have a clue for the selection sort. Select the smallest element in the array and exchange it with the element at the first position. Definitely smallest element कहाँ पर होना चाहिए?
First
First
position.
First
position.
position.
First position.
And in this way, we will get the sub sorted array, that is single element sorted हो गया यहाँ पर. Then in the remaining array, we will find the next smallest element. Okay. And then we will swap it with the second position. Then in the remaining element that excluded the two first elements, we will find the smallest one and then we will swap it with the third position.
Third one.
And so on we will do till the element is or the array is not sorted. That is how the selection sort will work. This is like I think simple in comparative to the insertion sort, because the main part of this algorithm is you just need to find the smallest element of the array. That is very easy. Smallest element, I think everyone knows how we can find the smallest element in the array. Yes or no?
Yes, sir.
So can anybody tell me how we can find the smallest element or the largest element of the array? Both the concepts are same actually.
I
A
AI
of I is less than
A,
equals to A of
A of AI plus 1.
Do not try to be technical at very first step. Just give me a
So
logic.
we'll just assume the first element to be the smallest one, and
Very
we'll
good.
compare it with the whole with all the elements in the
Very
array.
good.
And then
Very good.
if we find any other element which is smallest to the considered element,
Very
then we'll
good.
swap it.
Then that is okay. We're not swapping it actually. We can change the minimum
We will
value.
assign it to
Yes, sir.
that one.
Yes, sir.
है ना?
Assign. Huh.
We can assign it to the minimum variable that we have considered or initiated. We have initially taken. So I'm repeating it. Whatever the Divyanji I think says us. We will take a minimum. Let us say we will take a variable named minimum, and we will assign the first element to that particular variable minimum. It means we are considering the first element to be the smallest one in the array. Then we will compare that minimum variable with the other elements of the array like 2, 3, 4, 5, 6, 7, 8, whatever it is. And suppose if I found an element in the array which is lesser than that minimum value, then we will change the value of the minimum. And in this way, we will find the minimum of the whole array. And similarly, we can do for the maximum one. We will take a maximum variable in which we will store the first element and we will compare it. So in that, we will find the maximum one by changing the value if we find the element greater than the maximum value. So that is the main concept in the logic of the selection sort also. So what we need to do, basically, we need to find the minimum element among the specific list of the array, and then we will swap that element with the corresponding position. Okay, so loop ke according we will try to find out which position will be there in order to swap it. So the logic is okay. Is it okay or not?
yes, sir.
Yes, sir.
So the disadvantage of this particular algorithm could be like it could have the more time actually, because in this, first of all, we are comparing and we will try to find out the largest or the minimum element of the array. Okay, so for that we need to compare it with the whole array. So it will be almost of n squared, big O of n square complexity. Okay, now let us take an example. This is initial random numbers given to us. Randomly user has inputted some array, that is 8469231. The first step is, first of all, we will find the smallest element of the array. So this is pass number 1. Pass number 1, and we will try to find the minimum element, which is
1.
1.
1 is the
One.
minimum element, and we will swap it with,
8.
8.
so 8 and 1 will be swapped. Now this is the list, output list of the pass number 1. So in pass number 1, we will swap the minimum element with the first element. You see that 46923 will not change at all. Only 1 and 8 get swapped. Is it okay? So we need not to change the remaining elements. We just find the minimum and we will swap it with the first or second and third and so on elements. Now this is the output of the pass 1, and as well as it is the input of the pass 2. So in pass 2, the list is 469238. 1 is already sorted now. We will not take 1 now.
तो 2 का कंपैरिजन करेंगे.
2,
Okay. Now the smallest element will be 2.
2,
And it is pass 2. That's why we will swap the 2 with the second element.
4
You are getting it? So we have only changed the position of 2 and 4. That's it. The rest 6938 remains as it is. And the output of the pass 2 is 126948, out of which 1 and 2 is sorted now. And we have with us 69438 is as unsorted, and which will work as an input of the
इनपुट होगा.
yes. So now the minimum element will be
3 swap.
it will be swapped with,
6
6.
so pass 3 element 3, swapping element is 3. So it is again actually we are trying to find out कि कौन सा pass में कौन सा element swap होने वाला है. Is it clear now? So two
Yes,
loop
sir.
लगेगा. First loop लगेगा pass को control करने के लिए, है ना?
और
जिससे
सेकंड लगेगा स्वैपिंग के लिए.
swapping भी उसी में हो जाएगी actually. Now next 9462 में 4 और 9 will be swapped. Next is 6 and 9 will be swapped. Last one is 8 and 9 will be swapped. And this way we have got the final output list. So this is what the selection sort is. So select the minimum element of the list and swap it with the specific location. Is it okay now? This is the algorithm that we need to, we can write. Just go through it and ask if you have any issue. Set the minimum to the location number 0. That is, we have already considered or we have already discussed. Search the minimum element in the list and swap with the value at the location minimum. Okay. Then increment the minimum point to the next element. Right now, minimum जो है वो हमारे पास, like at that initial position, minimum is at the location 0, and after the whole swap, minimum will be 1. So we will maintain two things, right? In that case, one is minimum, which will hold the minimum value of the list, and second one is the location, say location of the first minimum element that you have started with. So in that case, location is 8 and the minimum is 1. You have got it? We need to
Sir,
see.
please repeat.
Yes. Let us say initially minimum is 0. Minimum is containing the index of the smallest element. Yes or no?
Yes, sir.
yes, sir.
So minimum is having the location 0, which is the first one element. Now we will also use or initiate a variable that is location, and that location will hold the value of the initial minimum value, that is again 0. Okay, in the first pass. So now we will try to find the minimum value of this particular list, and that is 1. So after the whole pass, minimum is actually what? Minimum is
6,
6. Very good. Last element position. Location of last element. So now we will swap 0 and 6. This. So minimum and location we will swap. So based on
Will you
the
repeat again once?
look there, like minimum and the location are the two variables that we are trying to use for holding the indexes of the array. Initially, when the stage 1 is there, minimum is at index number 0, and because minimum holds the first element, हमको पता है minimum कैसे निकालते हैं, तो minimum हम consider करते हैं कि it will be the first element. So A0 is the minimum. So 0 क्या index है? So m is equals to 0 now, and location is also 0. Okay, why we have take these two variables? So that at the end of the like after finding the minimum value, we will be able to find out that minimum value will be swapped with which index. So location gives me that index from which we need to swap it. Okay, so minimum will change, but location will not change for the pass. For a single pass, that pass location will not change. Location will be 0 now. Okay, and minimum is 0. We have initiated it, and we will try to find the minimum value of the list, and minimum value is at the index number 6. So minimum जो था वो कितना हो गया? 6 हो गया. Yes or no? The index in the minimum is 6, but location is 0. So now we know that किन चीजों को हमें swap करना है. So location, A location and A minimum we will swap. Now in pass 2, location is now
1.
1.
and initially minimum is also 1.
1.
And after the whole process, we will find that minimum is
5.
this one. 9.
Five.
It is 4.
4.
It is 4. So now we know that we need to swap A location and A minimum, A4. So this is the use of location in your algorithm. Is it okay? Yes or no? Any confusion now?
Sir, till the end of the pass, location will hold the minimum element.
Repeat what you want to say.
Sir, for a single pass, location will hold the address of the minimum element.
Yes. Location will hold the address of the first element. Sorry, not minimum. Minimum will hold the address of the minimum element, and location will hold the address of the element to which we need to swap.
सर तो मतलब अगर हम सेकेंड पास की बात करते हैं तो लोकेशन 4 पे ही रहेगा और मिनिमम 2 पे रहेगा.
मिनिमम चेंज हो जाएगा. मिनिमम 1 से स्टार्ट होगा, है ना, मतलब 4 से स्टार्ट होगा, एंड इट विल चेंज बिकॉज द मिनिमम इज 2 नाउ. सो आफ्टर द होल प्रोसेस मिनिमम विल बी एट 2. इट मींस इट विल होल्ड द इंडेक्स वैल्यू 4.
Okay.
And in next pass you will like 6 6 is there, so location and the minimum initially will be at 6. Okay, it means it will be 2 now initially, and minimum will change, location will remain as it is. So location will give me the location of the element or the index of the element through which we need to swap the minimum element. तो लोकेशन को मुझे इस तरीके से होल्ड करना है, अदरवाइज मैं कैसे पता लगाऊंगा मुझे स्वैप किससे करना है. I have find the minimum element, that is 1. Up now to whom I need to swap it? How I will like be able to swap? So that is how we will maintain the location, that is the position where we need to swap it. Now this is the algorithm. Select the minimum at the 0, search the minimum element in the list, swap with the value at the location minimum, increment the minimum to the point of the next element now, and repeat until the list is sorted. And this is the algorithm, function. So I think I should ask whether I need to see that particular algorithm or not, or you will do on your own. That is more simpler than that of that, है ना, हमें उससे ज़्यादा simple है ये.
थोड़ा algorithm दिखाना.
Sir, after swapping, we have to explicitly change the address of minimum.
Minimum, it means कि
Before swapping, the minimum will be at the minimum where we have the minimum.
to just see it that after swapping of 1 of 8, we need to change the minimum value now. We need to change the minimum to 4 now.
Yes, sir. For
After swapping
address.
2 and 4, we need to change the value of minimum, that is 6 now. So it is what about the pass actually. Okay. Increment the min to the next element. So we are incrementing the min to 4, now to 6, now to 9, and so on. Yes, is it okay? If anybody wants that, I need to show the algorithm also, I need to discuss the algorithm or the function also, you are free and you are like, you should say that I should discuss. Those are students, if they want, they should write. Then the whole class does not go for the same actually. So please tell me if any one of you, they have 40% code algorithm तो show कर रखी मैंने.
हाँ सर, वो कोड ना. हाँ सर.
Next slide.
Yes sir.
Look at that selection sort part. This is simple enough. First of all, we have find out the value of n, that is the length of a, and in that case it is 7. Okay, and we have started the j from 1 to n minus 1. Smallest we have taken, smallest it is similar to that minimum value. So minimum mein what we have taken is j. So we have seen that this is index only. Yes or no?
Yes sir.
This is index. I am not taking aj actually. This is index j I am taking. So smallest it is taking j, and for I equals to j plus 1 to n. So if it is like suppose, like in this particular algorithm, what we have assumed it, the index of the algorithm starts from 1. Index starts from 1. 1, 2, 3, 4, 5, 6, 7. Okay, and we have moved till this 6 only, as n minus 1 is there. Because at last जो एलिमेंट होगा उसको हमें किसी से स्वैप करने की जरूरत नहीं है, वो ऑटोमेटिकली अपनी पोजीशन पर ही होगा. Yes or no?
Yes sir.
Sir, please repeat.
In this, the algorithm is written by assuming that the indexes are starting from 1. So 8 is at the index number 1, 4 is at the index number 2, and so on. Okay, and the loop is, it means the value of n is 7. Total number of elements are 7. Okay, now j is 1 to n minus 1. It means it is 1 to 6. And what does it mean? Ki we are trying to like move or do the calculations till that point only. Why not for the last point? Because at the last point there is only single element. Again, the concept that single element is always sorted. So we are not trying to move or swap it with anyone. Yes or no?
So why not consider the first element to be sorted?
Yes, sir.
Why? Like how you will find in that case the minimum element? In like here we are not trying to find out here we are not trying to work out upon the sorted list. Here what we are trying to find out is the minimum element of the list.
So minimum तो 7th पे है ना?
ओहो, वो तो इस पर्टिकुलर केस में है ना. अभी मान लीजिए कि 1 लाइक ये जो 1 है लास्ट में वो फर्स्ट पोजीशन पे होता और 8 लास्ट पोजीशन पे होता, तो do not like try to stuck on that particular example that I am discussing. Be general point of view से सोचिए एक बार आप. So here I have not talked about at any point I have not talked about the sorted array. कहीं पर भी हमने sorted array की बात ही नहीं करी है. Okay, at last point I am just saying कि what is there, कि like do we need to now swap it with 9 with someone else? क्या 9 को कहीं और से swap करने की जरूरत है अभी?
नहीं sir.
क्यों नहीं है? Tell me the reason also.
Sir, because वो already sort होकर ही आया है इस पोजीशन पे.
और वो ऑलरेडी एक सिंगल एलिमेंट है और उसको हमें किसी से स्वैप करने की जरूरत नहीं है. So that's why I am saying कि we will move from 1 to 6 only. We will not take a loop for the 7. What is the need of finding the minimum of this single element? Is there any need to find the minimum of the single element? Single element में से minimum निकालने की जरूरत है क्या?
No, sir.
No, sir.
That is why I have tried to ignore it. If you will make a loop till n, it is again no issue. कुछ नहीं होगा इस लूप में, आपका एज इट इज चल जाएगा. लेकिन प्रॉब्लम कहाँ आएगी? एक आपका स्टेप बढ़ गया. तो इन दिस वे यू हैव इंक्रीमेंट वन स्टेप ऑफ योर एल्गोरिथम. इट मींस टाइम कॉम्प्लेक्सिटी आपने बढ़ा दी. तो यू आर गेटिंग इट. So is it okay now? Yes or no? Do not be silent. Be interactive.
Okay, sir.
इतना डल होके एक मिनट को डाउट है. आई एम नॉट ट्राइंग टू लाइक व्हाट वी कैन से इज इन हिंदी वी कैन से इट इज थोपना. मैं थोपना नहीं चाह रहा हूं. इफ यू हैव एनी डाउट यू कैन आस्क. इज इट ओके टू एवरीवन?
एक मिनट सर.
Anyone? If you want to ask anything.
सर हम J को 1 to n-1 बस एक लास्ट स्टेप के एलिमेंट का मतलब लास्ट स्टेप बचाने के लिए कर रहे हैं ना.
और बेटा नीचे एक और रीजन है कि आपने जो इनर लूप भी लगाया ना फॉर आई j plus 1 to n. Now suppose j is 7 है ना.
ठीक है.
So is there any value at j plus 1?
No, sir.
तो
So this loop will take some garbage value from that.
जे का भी चलेगा.
वो क्या करेगा? इसके बाद की जो भी कोई गार्बेज वैल्यू है, मान लो कि कुछ भी यहाँ पर वैल्यू है a b c d whatever it is, so वो गार्बेज वैल्यू पिक करेगा और उससे उसको कंपेयर करेगा. So somehow it may generate some abrupt results in some cases, not always, in some cases. So in order to avoid this also, we will try to restrict us to till n-1 only.
Okay.
This is another reason, and that reason I have already explained, that was there also. Why should we do one more step when there is no need of doing like finding the minimum of that one element and comparing it and swapping it with someone else? इसको आप swap किससे करोगे ultimately? swap खुद ही से करने वाले हो, तो क्या जरूरत है स्वैप करने की से खुद को? Yes or no?
Yes, sir.
So is it okay now?
Sir, if we are going to include the address from 1 to 6, then how we are going to swap the last element?
What is the need of swapping the last element?
The last element is already sorted because we have already
Okay,
sorted.
Ajay is asking about like how we can swap the last element 1 to 8. ऐसा?
Yes, sir. Because we don't have the
Inner
address to
loop. You
access it.
just see the inner loop also. Inner loop there is I that is from j plus 1 to n.
Okay. Then j plus
Then
one.
when j is at 6, then we can be able to access 7 also.
सर आप एक बार इनर लूप भी एक्सप्लेन कर दीजिए.
Yes, let me do it. Okay, n is 7. Then we are moving from like first loop is from j equals to 1 to 6. Okay, it means we have started from this. Like in this case also I have explained कि initially minimum की वैल्यू क्या है यहाँ पर? Minimum और smallest क्या है? 1. Location क्या है? 1. As per now our algorithm it is 1 and 1. Okay, so do smallest at j. So smallest is the variable which holds the index of the smallest element for my sake. Initially it is the first element that we have assumed 8. 8 is the smallest element for my assumption. Okay, now I am trying to compare it with the rest of the elements, and the rest of the elements will start from j plus 1. Is it okay? Because 8 will
Yes,
be compared with 4,
Yes.
then 6 and then so on. So the loop will start from j plus 1. Initially the value of j is 1, so loop will start from 2. In between the value of j is 2, then it will start from 3. And like one position ahead it will start. And like at the time of 9, suppose j is at 9, so it will start from j plus 1, it is 2. So 2 will be compared with 9 and 3 will be compared with 9 and so on. Okay, so do if ai इट मींस कि ए नेक्स्ट एलिमेंट जो भी आई, इट मींस कि जो इनकमिंग एलिमेंट्स, रिमेनिंग एलिमेंट्स हैं 4 6 9 2 3 1, if they are smaller than the already assumed element, that is 8, then we will change the smallest. Okay, तो smallest क्या है इस वक्त? Smallest is 8. Smallest पे क्या आया था आपके पास? 1. Sorry, j is 1, so 1. Okay, and after this loop and comparing all the remaining elements with the 8, we find that 1 is the smallest element. Yes or no? And in that case, smallest will be now 7. Yes or no?
Yes, sir.
Then finally, what we are going to do is we are changing or exchanging the aj and a smallest. aj is 1. So हम smallest element को पास 1 में किससे स्वैप करने वाले हैं? a1 से. Is it okay
सर
now?
एक्चुअली इंडेक्सिंग का कंपैरिजन कर रहे हैं ना।
इंडेक्सिंग का कंपैरिजन कर रहे हैं, वैल्यू का कंपैरिजन कर रहे हैं, ai एंड a smallest. Is it okay now? aj is 8 now and a smallest is 1. So we are swapping 8 or I. That's it. Now come on to the another part.
Sir, what AJ is
Sir?
holding?
So
What
एक बार
AJ of
last
J is
step
holding?
explain.
aj is holding the first element. j की वैल्यू क्या है? इस पूरे पास के बाद भी j की वैल्यू कितनी है?
1.
1. So मैंने क्या बताया था कि पास 1 में मुझे किससे स्वैप करना है? स्मॉलेस्ट एलिमेंट को.
First index.
फर्स्ट इंडेक्स से. सेकंड पास में मुझे किससे स्वैप करना है?
Second index.
ऐसे ही. तो ith पास से मुझे, सॉरी jth पास से मुझे किस इंडेक्स से स्वैप करना है?
Smallest, which is 1 or index 7.
यस. तो jth स्टेप में मुझे jth इंडेक्स से स्वैप करना है स्मॉलेस्ट एलिमेंट को. इज इट ओके? हेलो
Yes, sir, it's okay.
दिव्यांश जी, व्हाट यू वांट टू आस्क?
No, sir, it's okay. समझ आ गया.
ये तो अभी सर
Now one more loop for other persons. I am taking one more loop for this particular algorithm. Now let us suppose we are at that particular part. Now we have swapped with a and 8 and 1. Okay. Now what happens? The value of j will be
4.
next loop will start. j is index actually. j की वैल्यू क्या हो गई यहाँ पर? 2 हो गई. और स्मॉलेस्ट भी कितना हो गया? 2. Smallest भी j ही तो है. Just look at that. Smallest is also j. Yes or no?
Yes, sir.
So j2 and smallest 2. And now we will start comparing with j plus 1, it is 3. So we will start comparing with 6. And we will find the minimum element is at that index 2. So 2 का index कितना है? 4 5. It is 5. So we will swap. Smallest में कितना आ गया? 5. And then we will swap a2 with a smallest. It means ki 4 and 2. aj and a smallest. j is 2 right now and smallest is 5. So a2 and a5 को हम swap करेंगे. So I think it is clear now. Yes or no?
सर एक बार लास्ट वाला आपने अभी क्या बोला है? ये जी तो
aj and a smallest, it is 2 and 5. So we will swap 4 and 5.
हाँ यस सर.
Done. It is done.
यस सर अब आ गया है.
Okay. So this is what about the selection sort is. Now any doubt in this? Anything anybody wants to ask? Yes or no?
सर इसमें एडेप्टिव सॉर्टिंग सर अप्लाई कर सकते हैं.
क्या कह रहे हैं आप?
सर कुछ नहीं.
So anyone has any doubt? Then you may ask. Yes, please. It means there is no doubt. So can we move to the next algorithm of sorting? Say at least yes or no.
सर एक क्वेश्चन था सर.
Or I am assuming that nobody is there in this class.
हेलो सर.
Hello.
सर मेरा एक क्वेश्चन था सर. सर इसमें हम अडेप्टिव सॉर्टिंग एल्गोरिथम अप्लाई कर सकते हैं सर, जिससे कि एक जो एलिमेंट पहले से सॉर्ट है उसका कंपैरिजन और दूसरे से ना करना पड़े, जैसे इसका टाइम कॉम्प्लेक्सिटी कम कर सकते हैं.
So can anybody tell the answer of this question? Is this algorithm is following adaptive nature or not? Yes.
Yes, sir.
Is it following or not? Adaptiveness, is it following or not?
सर कर रही है फॉलो.
How?
No, sir.
सर बिकॉज
So-
जो भी हम स्मॉलेस्ट एलिमेंट फाइंड आउट कर रहे हैं उसका तो हम यूज ही नहीं कर रहे ना, वो एक तरीके से सॉर्टेड होते जा रहे हैं.
यस.
Or someone says no, so how it is no? You need to answer it also, give the reason also.
सर मेरे ख्याल से दिव्यांजलि राइट है सर, क्योंकि ये फॉलो तो कर रही है सर.
So I am asking, like, someone says no also. If someone has any doubt on this answer, then please ask. बताइए बच्चे. Today the response is too low. Why the response is too low?
सर आप ही बता दो, कंफर्म कर दो आंसर को सर, कोई नहीं बताएगा सर.
Definitely it is like visible ki it is following the adaptiveness property. Like we are not changing or we are not using the already sorted array. Are we using or finding the minimum of all the elements every time? No, we are trying to find the minimum of remaining elements only.
यस.
So it's
Yes, sir.
using the adaptiveness.
ओके सर.
Somehow we have not used the already sorted arrays. Somehow we are taking the help of already sorted arrays. Yes or no?
यस सर.
So this is about the selection sort. Any question, any other question you want to ask, then it is like you can ask. Otherwise, I need to move on to the next algorithm. Should I start the next one? We are starting the counting sort right now. So 2 algorithms we have done, that is insertion sort and the selection sort. Even 3 we have done in the last few lectures. So insertion, selection and bubble. Can tell me, name any of one of this in which we have not compared the elements. इन तीनों में कंपैरिजन हो रहा है या नहीं हो रहा है?
सर हो रहा है.
बबल में हो रहा है,
बबल में भी हो रहा है.
सिलेक्शन में हो रहा है,
हो रहा है
सर, और इंसर्शन में भी हो रहा है.
इंसर्शन में हो रहा है. But now the algorithm which we are going to start, that is counting sort. In this we will try to use some concept that is that does not require any type of comparison at all. So this is an algorithm in which comparisons will not be there actually. We will try to sort the array without comparison. Now come on to the, before starting this, just
It may be
go,
possible.
yes, it is possible actually. Okay, so just try to remember the concept of bubble sort. Bubble sort, binary search. What is binary search?
So binary search में हम सर जो array और list है उसको 2 पार्ट में डिवाइड कर देते हैं.
Anyone else? What is binary search? What is the logic of binary search?
So we are searching in a sorted array
Okay, very good.
in which we find the middle element if the key we are finding is smaller or greater, depending upon that we moves in 2 of the 1/2.
Very good. So can we use some sorting algorithm in this to sort the array?
What, sir? Repeat the question, please.
My question is that is the sorting of the elements is the logic of that particular binary search? क्या sorting भी इसके logic में involved है? Or we have initially assumed that the sorted elements we have only?
So at that time when you teach us, we assume that the element is sorted, but at general purpose, we need to be sort the element before using binary search.
Very good. So we have assumed initially कि elements are always like given to us, it is sorted, and only that we can apply the binary search logic. So now consider that particular part in which we have find out the complexity of binary search. तो binary search की complexity निकालते हो क्या हमने sorting की complexity consider की थी?
No, sir.
What is the complexity of binary search? Log n.
Log n base 2.
हमने क्या इसमें sorting algorithms की complexity को देखा था, logic को देखा था कहीं? नहीं देखा.
We just
No,
assume that we are sorted.
Yes, that is what I want to again fetch out in this counting sort. In this counting sort, the assumptions are some assumptions we are trying to have, and on the basis of that we will not compare anything. What is that assumption? That we already know the largest element of the list actually. Okay, now how you can find the largest element? अभी just हमने we have seen and discussed in the selection sort. So the same way we can use to find out the largest element, but in that case the comparisons are required or not?
So
Yes, sir,
in
required.
Finding the largest element.
Required, very good, required. But what we assumed in this already, as we have taken an example of binary search, and in that we are not taking the sorting of the array into the logic of the binary search. Okay, similarly here we will not taking the finding maximum value in the logic of counting sort. Okay, other than that, what is the logic of counting sort? It will not have any comparison. Now got it? So what we have assumed that initially what we have given with is we have given with a list of n elements, okay, which is the list of n elements ranging from 0 to k. It means there are total number of n elements and the minimum value is 0 and the maximum value is k. That we have already known. So it is given to us prior to the starting of counting sort. So यदि नहीं भी दी गई है तो हम पहले फाइंड आउट करेंगे, लेकिन वो उसके लॉजिक में नहीं आएगा. जब भी काउंटिंग सॉर्ट पर लॉजिक लगेगा वहां पर कहीं पर भी कंपैरिजन नहीं होगा. ये कंपैरिजन कहाँ हो रहा है? ये कंपैरिजन हो रहा है फाइंड करने के लिए क्या? मैक्सिमम एलिमेंट. दैट्स इट. So have you got the point?
Yes, sir.
Okay. So I am now
last statement repeat करना सर.
हाँ, last statement मेरा बहुत बड़ा था. So counting sort assumes that each of the n input elements in an integer in the range 0 to k, where 0 is the minimum element and k is the maximum element. So by default, we know that what is the largest element of the array. Because in order to sort the elements using counting sort method, we should know the maximum element of the list. And we are assuming that that list is given to me and the largest element of that list is also given to me initially.
Okay.
Okay, that is k. Now that is total number of elements are n and the maximum element of that n elements are k. Now consider the input set 4, 1, 3, 4, 3. What is the value of n in that case?
5.
N equals to
And
5, K equals to 4.
what is k? K is the largest element and that is 4. Now you also see in that case, in this we are trying to have duplicate elements. So counting sort is best for the list which has a duplicate element. Or in one other sense, you can also say that it is best in terms of the time complexity because it is a linear sort algorithm. It means it sorts the list of an array in linear time. Definitely linear time is the best time or we can say the minimum time taken among all the algorithms we will study. Is it clear? We will see how actually. Like in the previous two, you just come up again selection sort. What could be the time complexity of this algorithm? Can anybody tell me? How many loops are there? One is that loop for, and one is another loop that is inside that loop. So this
Big
is
O of N square.
Big of n square was
डेफिनेट
case.
डेफिनेटली है ना. इस पूरे केस में मैक्सिमम जो
तो
वर्स्ट में n स्क्वायर आएगा. सिमिलरली इन इंसर्शन सॉर्ट वी हैव टू लूप्स. आप जब आप बनाओगे तो उसमें दो लूप आएंगे तो कभी भी वो लीनियर नहीं होगा. क्या ये लीनियर हो सकता है किसी केस में भी?
No.
लीनियर
No,
मतलब
sir.
n की पावर 0 सॉरी n की पावर 1
No.
है ना.
No.
but in the case of counting sort you will see it will not have any like nesting of loops. In this way we can say that it will be linear. It may be linear in the worst case. So it is best among the available options of the sorting algorithms till now. आपने जो आप पढ़ोगे उसमें से बेस्ट एल्गोरिथम होगी जो कि आपको सॉर्टिंग करके देगी लीनियर टाइम में. तो इसको हम लीनियर सॉर्ट एल्गोरिथम भी कहते हैं. जैसे लीनियर सर्च होता है वैसे ये लीनियर सॉर्टिंग एल्गोरिथम होता है. इज इट क्लियर टू ऑल नाउ? तो इसके खूब सारे फीचर्स हैं. सेकंड थिंग इज दो चीजें पढ़ चुके हैं हम लोग. फर्स्ट वन इज इट इज नॉट कंपेयरिंग एलिमेंट्स. Like in this main logic, we will not compare any elements in order to sort. Second one is it is linear time algorithm. And third one is it is stable algorithm also. What is the meaning of stability? Stability
So
का
in
मतलब
case of duplicate elements, the relative positions will not change.
very good. So it also uses or it also reflects that particular concept. So output of that list जो होगी उसमें relative order जो होगा duplicates elements का वो maintain रहेगा. That is again a very important features. क्योंकि इसमें आप सपोज करो फर्स्ट इन फर्स्ट आउट वाला कंसेप्ट लग रहा है यदि आप इसको अज्यूम करके देखो तो. यस और नो?
Yes, sir.
So that feature is again the part of this stability. So first in and first out. It means ki the order in which the elements are inserted into the array, they will be in the output list in the same order. So that also follows the first in first out concept, stability. Even insertion sort also follows that. Okay, so that is the features of this counting sort. So counting sort determines for each input element x the number of elements. कैसे वर्क करेगा ये देखते हैं. ये स्मॉल लॉजिक लिखा हुआ है मैंने पूरे प्रोग्राम का, है ना. ये दिस इज द स्मॉल लॉजिक through which you can understand the whole algorithm concept. कैसे? Counting sort determines for each input element x the number of elements that are lesser than that. काउंटिंग सॉर्ट क्या करेगा? ये आइडेंटिफाई करेगा कि किसी नंबर x से कितने नंबर ऐसे हैं जो उससे छोटे हैं, एंड देन it will be able to identify the position of x. कैसे? Now suppose there exists 17 elements lesser than x in a given list. So what will be the position of x in the output list?
18.
18 definitely. So सबको समझ में आएगा ये चीज? Yes or no? We will try to find out the elements, number of elements which are lesser than the particular element, and based on that we will try to find out the location of this particular element. कैसे हम देखेंगे, अब ये भी बिना कंपैरिजन के करेंगे हम लोग. Look at that, it is very interesting algorithm actually. Okay, now this algorithm uses 3 arrays. एक ऑक्सिलरी एरे भी, एक तो इनपुट एरे होगा, एक आउटपुट एरे होगा, एंड एक ऑक्सिलरी एरे होगा जो कि हेल्प करेगा हमारी आउटपुट एरे प्रोड्यूस करने के अंदर. So how many arrays we will have in this? 3 arrays. One is input, one is output, and finally, and in between we have a sorted, a temporary array, that is auxiliary array, that will hold the intermediate results step by step. Okay. Now,
सर तो फिर सर इसका टाइम कॉम्प्लेक्सिटी n क्यों होगा क्या? big O of n की
क्या कर रहे हो
सर? इसका टाइम कॉम्प्लेक्सिटी क्या होगा फिर? इसमें
किस
3
चीज?
लूप इस सॉर्टिंग एल्गोरिथम का सर.
मैंने ऑलरेडी बताया कि इसकी सॉर्टिंग एल्गोरिथम का टाइम कॉम्प्लेक्सिटी कितना होगा. आई हैव ऑलरेडी डिस्कस्ड. एनीबॉडी कैन टेल मी?
big O of n or theta of n.
Big O of n. It means it will be in the linear. It will be in linear form. We will see how बेटा. हम देखेंगे कैसे बेटा. ठीक है. मल्टीपल एरे यूज कर रहे हैं, इससे टाइम कॉम्प्लेक्सिटी में कोई फर्क नहीं पड़ता है. इससे स्पेस कॉम्प्लेक्सिटी में फर्क पड़ सकता है. यू कैन से दैट इट विल टेक मोर स्पेस. Yes, definitely it is a drawback of that algorithm, counting sort. Counting sort का algorithm का drawback क्या है कि it consumes more space than that of the some other algorithms. Like क्या हमने insertion sort में, bubble sort में क्या हमने कोई auxiliary array use किया था?
No, sir.
Output array use किया था?
नो.
हमने उसी input
पास का जो
we have only taken the initial array and in which we have performed some calculations and we have get that array only sorted. So suppose initially I am having array A array, the output array is also A. Yes or no? We have not changed at all. आप algorithm यदि compare करोगे so आप देख भी सकते हो in insertion sort. देखो यहाँ पर क्या हमने कहीं B array use किया है?
No.
तो array A में ही sorting हो रही है सारी. So here we are using two more arrays in order to sort the elements. That is obviously a drawback of the counting sort. And one more drawback is that, like suppose मेरे पास केवल 2 ही मतलब मेरे पास केवल 5 ही एलिमेंट हैं. Like this particularly कंपेयर करते हैं हम इससे. अब सपोज मेरे पास एक एलिमेंट है ये. How many elements I have?
5.
5 elements. The maximum element is
This
Third
one.
one. 10 lakh.
third one. Okay, so the like the size of temporary array you can see now. Input array का size क्या है? 1 to n. So input array में 5 elements. Output array में कितने elements हैं? 1 to n. The size of 5. Temporary array, auxiliary array जो intermediately use होने वाला है in order to sort the elements. What is the size of that element?
1 to k means largest element.
Largest elements. So what will be the size of C array in that case? In this example, 4 1
Third one.
4 1 10 lakhs 4 3. क्या होगा इसका size?
10 lakh.
10 lakhs.
1 to 10 lakh.
So that is what the drawback of this algorithm also. So you have got it. मेरे पास केवल 5 एलिमेंट सॉर्ट करने हैं, लेकिन मुझे जो इंटरमीडिएट एरे लेना पड़ेगा वो मेरा किस साइज का होगा? 10 लाख साइज का होगा.
Memory wastage.
That is the drawback of the counting sort. I think it is clear now. Even if this is the element I have taken, suppose 999 भी लेता हूं यहाँ पर मैं, तो भी क्या होगा? तो भी मुझे 999 साइज का एलिमेंट लेना पड़ेगा in order to size in order to sort only 5 elements. So with the help of that you can understand that what is the drawback of this particular algorithm. Is it okay now? Yes or no, say at least.
Yes, sir.
फिर तो ये तीनों सॉर्टिंग एल्गोरिथम में से सबसे बेस्ट हुई.
ये in terms of time it is best, in terms of space it is worst. In single line I can say that. सो इतना समझा दिया मैंने. आई थिंक सबको एक संग यस बोलना चाहिए था. शायद समझ में भी आया होगा सब लोगों को. आई थिंक.
Yes, sir.
Yes, sir.
So the logic is, now we will see the logic actually. Okay, so algorithm uses 3 arrays: input array, the n size, output array with n size, temporary array with the size up to k. Okay, and this is a sorting algorithm. I am skipping it and now I am coming onto directly onto the example. Okay, algorithm आप खुद लिखोगे. Should I move or should I stop? Tell me. It is 2:28 already. Should I like मैं इसको continue करूँ?
सर थोड़ा रिवीजन
सर
बताइए मुझे पहले बता दीजिए ताकि क्योंकि it takes time, at least 10 minutes it takes. So should I continue or should I stop? यदि हम stop करेंगे तो मुझे next lecture में वापस बताना पड़ेगा.
स्टॉप सर.
Stop करूँ?
सर स्टॉप कर दो सर. क्यों
Everyone agrees with that?
सर कल से रिवीजन हो, कल अगर आप बताओगे तो और पक्का हो जाएगा सर. इससे रिवीजन भी हो जाएगा इसका.
Okay. So I think we have discussed the logic, and now in the next class we will try to understand the examples or steps that the counting sort follows actually. Okay. Is there any question from your side?